Imagine being 4 years old on a fishing boat off the coast of Mexico. The adults are cheering over their catch. You lock eyes with a dying swordfish and make a vow on the spot. A vow to spend your life defending the ocean. That moment set one kid on a path that would eventually lead to one of the most ambitious scientific projects on the planet. A project that tries to map every marine species that lives now and where they might be headed as the ocean changes. When we come back, you'll meet the scientists who turned that childhood vow into a global mission.
Seafood isn't just a dish, it's a global story. The Decoding Seafood by Mowi podcast series explores the science, sustainability, and surprising truths behind the seafood you love, straight from the voices of those shaping the industry. From chefs, scientists, influencers, and insiders who live and breathe seafood and uncover what most of us never see. Hosted by Chef George Duran, you can find Decoding Seafood here on your favorite platform and at Mowi Salmon TV on YouTube.
Welcome to Decoding Seafood by Mowi. I'm your host, George Duran. Today's guest is someone who has devoted his entire life understanding the hidden journey behind the seafood we all love at a level that borders on the impossible. Gabriel Reygondeau is the associate professor at the University of Miami and also at the University of British Columbia. Gabriel, thanks for being on the show.
Thank you for inviting me.
Now, tell me a little bit more about AquaMaps. For the basic layman, the regular person, you tell them, hey, I work on this project called AquaMaps. What would you tell them exactly? What is AquaMaps?
AquaMap is a project or website, to be more clear, where we try to provide the map of every living organism in the ocean. So to know where all the organisms are located in the ocean and where they are now and where they will go in the future.
Okay. That's like sounds like superhero material. That sounds like it's almost like impossible to do. How would you possibly be able to get species information throughout this massive ocean that we have out there, and to be able to directly locate these species on a live scale? Is that what it is?
So the idea is that we have websites that are funded by United Nations that record every observation of every species in the world. Okay, so we have the record of that.
How do they do that, by the way? How do you record?
Museum, scientific surveys. Okay. They need to host their data somewhere, and so the UN provide those websites.
Okay, so we know what the species is. Now the question is, how do we know where they are?
You have a GPS location.
I don't understand. How do you know that there's whale in certain parts of the ocean? Like, are you going and surveying it there?
Or even tourists, or even whatever type of observation you will get, like expert going on a survey, fishing boats, observation from satellite, tagging, anything where you can go down to the species level. We can record it, store it, and that gives you the occurrence. So is the species here at that GPS location, and at that month, that day, that year. And we have that for almost 150,000 species.
Come on. So how are you distinguishing where the species are at any given moment via database? Like, how are you all communicating to each other that there's this database, the internet? Okay, I've never heard of that one before. So there is a central database, you're saying?
Yes, there is two big databases. It's called OBIS, Oceanographic Biogeographic Information System, and GBIF, which is a terrestrial database. They were mostly terrestrial, and they started to host some marine data. So these two databases host most of the information on every species in the ocean. Then my job is from seeing one species one time, trying to have mathematical tools, nothing very fancy. It's kind of AI thing. And using that AI, mapping at a global level.
Amazing. So a fisherman goes out to sea, suddenly sees a pod of dolphins.
Yeah.
And
now you need to catch it, because you need to bring it back to
you have to bring it in. You can't just radio it in and say, hey, I saw dolphins in this.
Dolphin is not a species.
Okay. Let's go back then. Let's talk about species that we do consume. They see a swordfish.
A swordfish is a species.
Right.
So if you see a swordfish, is it identified? Like if you catch a swordfish, it's identified as a swordfish. We agree, as a fisherman, you need to bring it back to the port.
Well, what is the incentive of that fisherman to report it to that database?
The incentive is that he's going to sell the swordfish. And so that's called the observation. So we have observer in every port in the world, which is based on economics. So when you bring back all the species that you have fished, we agree that you need to sell them. So in order to sell them, you need to know which species it is. So you have observer on the port. So basically the observer will say that's that species, and you will know how much tons of a species you will have at the port and where the fisherman went with this GPS location. So you will know where the species were, at what time, and how many.
So these are independent observers going out there, just standing out there waiting for them to arrive with their catch. And then asking them. That's
one part of the data.
Of course.
Then you can add the scientific survey, because we are talking about fish, but for plankton, nobody is selling plankton.
Right.
So you need to go on scientific survey for that. Or there is a machine called the continuous plankton recorder, which is attached to vessels that are going from Europe to America, like, to traveling vessels or shipping vessels. And it's a little machine big as this table, and it records continuously what is in the water. And at the end of the travel, there is taxonomists that are looking in the bend and identify species by species. And since you know how much bend you had, what was the trajectory of the boat, you know where the species were.
Incredible. So you've taken this data, applied it in some sort of machine learning.
Not some kinds, machine learning.
And well, you've figured out where all the species are throughout the ocean on Earth.
Yeah.
That's the what. Then what about the why? Why are we doing this?
In order to understand how the system functions, you need to understand biodiversity. And biodiversity, same than on the terrestrial, rests on the lower level. And on each level, and basically who eats who. That's called the trophodynamic. That's a fancy word to say who eats who. Where there is more species, you expect more trophodynamic, and so potentially more biomass. So the amount of organism, of living material in the ocean. And basically knowing where species are is the way to better protect them. And that's my job, basically trying to find a way to know where all the species are in the ocean in order to understand their linkage with the humans and the linkage with the climate. And once I understood that, I can provide those information to countries or to United Nations in order to protect them.
Give me an example of how you would protect a certain
Marine
species.
protected area, for example.
So you would tell the country, hey, look at the coast of Chile. There's these.
Usually it's the inverse. The country coming to us.
Oh, the country coming to you. Why would the country have any
because
incentive?
we are the biggest database on biodiversity.
So what are they asking you?
Maps of biodiversity.
And once they know that, again, tell me about the protection of these species. How is the country saying you cannot fish over here?
It's you have 4 degrees of marine protected area in the world. There is either recreational, so that would be a park or something, up to no take, no inclusion, like not even a boat can enter the water. So you have all these degrees. So basically, they ask us or me or OBIS or this kind of, they need data. And in order to have this data, we provide them the data, and either we perform analysis to tell them, okay, economically and scientifically, for fisheries, for biodiversity reason or economical reason, this place is the best. And then you need to include, for some country that believe in it, climate change. And so if you protect a place that will work for 5 years, but I will tell you that in 10 years, the species will not be there because of climate change, there is no incentive for you to protect it. So that's one other metric that we are providing to them.
So you're getting almost like a futuristic look of what the ocean.
We're
trying now to get a futuristic look of what the oceans may look like, so that you can protect it now, so that in the future you'll have all that biodiversity, which is important for the health of the ocean.
Important for not only the ocean. Like, we need to stop dividing the ocean and the terrestrial in such a manner that it's not interlinked. First of all, we are the blue planet.
Right.
Let's start with that. Whatever we are doing on the terrestrial will impact the ocean. Whatever the ocean is changing will impact the terrestrial. It's a loop. It's a closed loop. Okay? The marine organism, something that people tend to forget is most of the oxygen that we are breathing as humans is not coming from the terrestrial. It's coming from the ocean. So if we break the ocean, we cannot live on the terrestrial. Let's start with this basic thing. Second, in terms of number of gram of carbons that we are consuming on Earth, most of the small island in development or coastal country will have from 20% to 50% of their daily income from fish or other seafood.
Right.
So you see, this terrestrial ocean link is more fluid than you think. Protecting the ocean is protecting the terrestrial.
Amazing. How does this translate to fisheries, aqua farming? What are they doing with this data now? Are they moving the pens? I mean, how do they actually get this data? And
That's
how
a
does
big jump. Fisheries, they fish.
Yeah.
Fisheries doesn't really take into account. They try. Let me rethink this. Can we do a small thing?
Yeah,
You need
of
a
course.
slide.
If you're joining us on the YouTube channel, you will notice that there's a lot of visuals also for this podcast, which is fantastic. So by all means, tune into the YouTube channel so you can watch this. If you are listening, just click on that YouTube channel, Mowi Salmon TV, and you'll watch this episode.
We'll be back after this break.
Mowi salmon comes ready to cook, ready to grill, ready to season, or pre-seasoned and ready to eat. And an assortment of flavors for an assortment of people. Mowi salmon.
So let's go to some visuals so we can actually see what we're looking at.
Thank you.
here.
Okay, so that was AquaMap. We spoke about it. You can
Okay.
continue. This is the new AquaMap. So
Do you want to talk about the new AquaMaps?
Oh, yeah, I'm fine
All right,
with that.
So it sounds like you have AquaMaps 1.0.
yeah,
And now you're working on AquaMaps 2.0. What would be the essential difference?
the essential difference is everything.
Yeah.
So basically, AquaMaps 1.0 was developed in 2002. The tools in 2002. I don't know how old you are, but
Yeah.
you remember 2002.
Of course, I do.
When
I do.
Spice
I'm
Girls
old.
were the
yeah,
thing.
Yeah.
The tools, the numerical tools that we have now are way more strong than the tools that we had in 2002. And so when we changed AquaMap from AquaMap 1 to AquaMap 2.0, we increased the resolution, went from a simple model to machine learning, went from one source of data, you remember the occurrence data,
Right.
to everything with agreement with all the institute of the world. We now have different scenario on climate change. So basically, depending on how the government's going to decide the future of the Earth, we have different scenarios on how the ocean will react. We have, of course, uncertainty and spatial uncertainty, and we have new indicator of biodiversity, because biodiversity is not only the amount of species in a place, it's also how rare they are, or how genetically rare they are. And so now we provide all these new tools to the world at 5 kilometer resolution from now to 2100.
Amazing. So in a 5 kilometer, that means you can tell what species are living
Yeah.
in a 5 kilometer square
Yeah,
area.
5 by 5.
5 by 5, which is tiny compared to the size of our ocean.
Yeah.
Currently, it's what with 1.0?
What do you mean?
What's the current resolution?
No. So the 1.0 is discarded now. We are
it's
already at the 2.0
You're
now.
already at 2.0, 5 kilometer resolution.
So
That's-
the 1.0 was 55 kilometer resolution. So we
Right.
are 10 times smaller now.
and it's amazing. You go to aquamaps.org and
That was the 1.0.
and you go to aquamaps.org. This is 1.0.
That's
and,
1.0.
And so the colors are essentially telling us
The number of species.
the number of species, and then you can kind of click on what you want.
Oh, you can take your mouse and
Yeah.
click anywhere in the ocean,
That's incredible.
and normally it will give you the species list.
That's look at that. That is incredible. I mean, that's insane. You can literally.
And
I
now
mean,
click on one of the species,
Yeah, we'll go
for
to.
example. Okay, and now you're on the fish-based database, and if you look at the map,
Yes.
so here you're on the big-eye tuna, which is one of the most fish species in the world. And if you look, you see native range, all suitable, point map, and year. So can you go on point map quickly? Here, yes. So this is all the observation we were talking about with the fishermen.
Amazing.
So now go to native range. That's what we suppose based on the model where the species is. Red means the species is here, yellow means less likely, blue means most likely not. And now put year 2050. That's where it will be in 2050.
Incredible.
And that was AquaMap 1.0. 2.0 is even more complicated than that, and give you more information than that.
All right, let's step back for a second here. Where are you from? How did this all come about? What inspired you to get to this position? Because there's a very interesting story that I started off the podcast with when you were a very young child. Tell us about that moment.
The moment of my childhood.
Well, both, I guess. It started with that moment, I assume.
So obviously, and I apologize for that, I have a huge French accent because I'm French. But
I couldn't tell, but go on.
could be Québécois.
Right.
So I am French with my passport, but I did not grow up in France. I grew up my parents were working for a travel agency called Club Méditerranée, Club Med.
Sure, Club Med, of course.
And so we were changing country every 3 months or 6 months. So until my age 12, I was basically between Africa, the Caribs, Asia, and Latin America. And I arrived in France more than usually my parents were stopping 2 weeks in France, and then we were going back to the world. And I settled, I did not settle. My parents settled when I was age 12, 13. And then from there, I done my study in France because it's pretty good reputation. Done my bachelor and master's. And then starting from the PhD, I went back to traveling with a PhD between France and South Africa. And then from there, basically, I was in Denmark, Norway, Yale, and for 12 years of my life in Vancouver.
What motivated you to start something like AquaMaps?
AquaMap itself or numerical ecology. So basically, I vow, as you said in my story, at 4 years old, I decided I will protect the ocean, and I never eaten any seafood except one time. I always do one time for the taste because it's dumb to be too restrictive.
Right.
So I always try every product one time, but then I don't touch seafood and fish. Then I decided to go for to go for protection of the ocean. You're 10 years old. You don't know what you're doing. So basically, you follow the education system that brings you to marine ecology and oceanography, so physics and biology. So I decided to stay in between. And I'm going to tell you the same story than all the scientists. I met a good professor that taught me statistics and mathematical equation, and I fell in love with modeling. And then I was like, there is a lot of people working at the local scale and regional scale. There is not a lot of people working at global scale. And it was around the 2000 area. And if you remember at that times, Al Gore just released An Inconvenient Truth.
Right.
And that really resonated with me. And that was the moment where climate change was starting to be a big topic in the news. And there was not too much science in the ocean about it. And I found my path. And so I found global climate change and modelization. And that brought me to biogeography. And what was the biggest website of biogeography was AquaMap. I learned my pathway to go to Denmark to take all the technique of the terrestrial people because Denmark is one of the biggest center for biogeography in the terrestrial. Then I went to Yale, which is the second biggest. I took all the techniques of the terrestrial people and brought it to the ocean, and became the leader of AquaMap. Amazing.
Let's kind of focus a little bit on salmon because after all, this is Decoding Seafood.
I have some slide on that, but yeah.
Yeah, let's take a look at
the problem with salmon. There is one thing with salmon.
Yeah.
Salmon is diadromous, meaning that it's both in the ocean and in the river. So when we're going to talk about salmon, also plenty of species of salmon. So when we are talking about salmon, we need to talk about all the species of salmon and both rivers and lakes and ocean.
Interesting. Very different, very distinct. But if we talk about Atlantic salmon, we're talking about the salty
the native distribution or the invade distribution?
Well, I guess the native distribution, but
then you know where we are. It's basically north of Europe.
Yeah, north of Europe, and then how does something? Let's talk about AquaMaps and how that helps perhaps someone like who's in aqua farming, for example. How would that help a fishery or an aqua farmer?
You mean mariculture?
Yes.
If you assume that you're growing a species where you control most of the parameter, we agree, and you know the genetic of the species, and salmon is not a random choice. Salmon has been chosen because it is the species the most studied on the diadromus that you can cultivate.
Yes, and tasty too. Let's not forget. Yeah.
Is it a causality circle here?
Right.
So it has been selected because it was tasty. You need, like the beef.
Right, correct.
Like the beef, like the chicken, like anything that agriculture is doing. You find something that is tasty, you try to make the production as big as it is, as big as you can be, with reducing the cost.
Right, and also perhaps reducing any sort of footprint.
That is usually, let's be honest, that's the second step.
Right, but it's a good second step.
Yeah,
to
that's
have,
a good. Then it should be a first step.
And also, you can taste it too when you have the quality and you're thinking about your surroundings and
I trust you.
what the fish are eating. At the end of the day, the quality is right there.
So the thing with the salmon, it has been, especially the Atlantic salmon, its biological cycle is perfectly known. That's why it's farmed, and that's why it's you can make profit about the farming because every little variable is controlled, except one. If you're doing mariculture, that means that you're farming in the ocean. A fish is dependent on temperature of the water. If the water of your ocean is getting warmer and your fish is blocked in a tank, your fish is going to die.
Right.
Just by the fact that it's too warm for him.
Of course.
So what AquaMap can provide to the aqua farmers or even the fishermen is helping them. I'm thinking for the artisanal fisheries, not industrial fisheries.
Right.
We can provide them, if you're in a certain point, let's be honest, like fishermen stay next to their port for a lot of reasons due to the cost of the gasoline, for example. We can tell them, okay, for the last 80 years, you have been fishing this. But in the next 50 years, depending on how the climate is going to change, these are the species that are going to come from the south. That will be your new fisheries. Amazing. For the salmon, the mariculture that are located now are optimized for the center of the window of basically you and me, we have a temperature that we like. Same for the salmon, except the difference is that the salmon, its temperature, inside temperature, depends on the temperature outside. So if the temperature outside shifts, is inside is not getting good. So what AquaMap can provide is telling to the companies that are doing the aqua farming, if you want to be sustainable within the next 40 years, this is the point where you need to be because the temperature will not change significantly for the species.
Amazing. You really can pinpoint.
I can pinpoint exactly the location, on both ocean and river.
Yeah. Is the entire world using this process? I mean, are you going to Asia, for example, and they're also... No.
Okay. For now, the process... The question is always... For the mariculture, people tend to optimize where the government gives you subsidies.
Right. Well, that's true for a lot of farming.
And so the question is not what is the best for the species, or the question is what is the best for your company.
For your pockets, right.
And so do they listen to us? When they're poor, yes. When the subsidies are massive, less. Yeah. And so for now, we have not been very climate smart on our mariculture and on our fishing.
Yeah. It's important to know where your fish comes from.
It's crucial.
Yeah.
And what do you mean by that? Do you mean genetically, or do you mean is it sustainable in their fisheries?
In both ways, I would say. I think, we go through the supermarket aisle and look at the ingredients, where it comes from, perhaps where it's made, even through the clothing rack. Where is this made? What is the ingredients made? We don't do that enough in the fish department.
Starting to come, like since 10 years. So I don't know if you have heard about the work of Daniel Pauly. So Daniel Pauly is the first person that have collected all the catch of the world and reconstructed all the catch of every nation of the world. It's the project is called Sea Around Us.
Okay.
And then he basically showed that the catch of the world have been increasing until the 90s and then stabilized and now are decreasing. The twist in the story is that the number of vessels is still increasing. That means that you have more boats, more effort, but the result is lower.
Is it because we have less fish?
Yeah.
Yeah, that's it.
Because basically we have overexploited lots of species and always kind of the same species.
Right.
And so we didn't let the population renew their population. Right. So basically you were always attacking the biomass at a point where the new biomass could not even emerge. And so coming back to sustainable fisheries in the sea around us, the sea around us can tell you for which species in which country do you fish sustainably the species? Do you catch not as much individual that the population can renew?
Right.
It's called the MSP.
Right.
MSY, maximum sustainable yield. And a company in Canada and that you can find in US that is sponsored by Oceana and Oceanwise, I've created the MSP logo that I'm pretty sure you saw in New York.
Of course.
MSP logo come from that science.
Right. Oh,
and so when you see MSP, it means that your fish has been fished in its natural water on the maximum sustainable yield, meaning that the population is not overfished.
Right. And just like ASP as well, for the aqua farming, you know, these are organizations.
ASP is the child of MSP.
Right, and essentially, what you're getting is this certification with what the fish, in this case salmon, perhaps that you're purchasing. You're knowing that they're doing it sustainably, and it's a third party, right? At the end of the day, it's not just them kind of saying, I want to put the stamp on it. There's a lot of process to get the certification on the fish.
Oh, it's very hard.
And it's what I look for when I go into the fishmonger or into my local supermarket. I'm looking for a lot of these stamps. That it doesn't mean nothing. There's a lot to it.
There is science behind it.
At the end of it. The biggest point of discussion that I have with a lot of guests here is, how do we feed this massive population? How do we feed them the best form of protein, in my opinion?
Plankton?
Plankton. Okay, we can do plankton too. I'm not there yet. I might pass on the plankton for now. But how do we? I mean, we can't just overfish our oceans. We just can't.
We are doing that.
Right. We're not supposed to be doing that. So we have to resort to what we do on land, which is farming at the end of the day.
Yes, but there is a catch to the farming and to the aqua farming is we don't know as many species on land that we know in the ocean. What I mean with that is currently, let's be real. Let's be into the market of aqua farming. Yeah. How many species are farmed? Like commonly?
I don't know, a handful?
I would say 3 or 4, 5 maximum.
Yeah.
How much does it cost? Because there was a time people had ideas to try bluefin tuna. Bluefin tuna is the most expensive species in the world. One bluefin tuna is sold, one individual that is big between the size of the bluefin tuna will be from this table to you. You know how much it's sold at the Japanese market, the first one?
Yes, I always hear about these stories. Like
$240,000.
Yes, I'm not surprised. Yes.
You don't think that one guy said, let's farm that thing?
Yes.
Yeah, it has been attempted in Croatia and Norway.
And?
Succeeded.
But
why don't we don't hear about it?
I don't know.
Because you lose money.
Oh.
Because we don't know enough about the biological cycle, and those species need space. And if you need space, you need more money because you need your tank to be crazy big.
Right, but that's why we have these ocean pens that we can set up.
It's not big enough.
It's still not big enough?
The Atlantic bluefin tuna performed migration between France and Florida.
Okay, but let's talk about a smaller species that doesn't need as much space.
Yes, but I'm trying to give you the logic behind that. If we can't farm the most expensive species in the world, then we're going to go to the lower species of the world. But that means that you need to do science on their biological cycle.
Right.
For now, this effort has not been done. We have incredible knowledge on the biological cycle of terrestrial species. Right. Different cows, different chicken, different pork, species of pork that we control perfectly. That's massive production. we have that for the salmon, tursiops, and I think a couple of anchovy. That's it.
Not sea bass.
Maybe sea bass.
Right.
I'm not a specialist of aqua farming.
Right. That's fine. We have to start somewhere.
And the incentive is increasing the amount of species that we know and trying different location, because most of the farming are always in the same areas of the world.
Right.
And maybe have an incentive to develop this aqua farming, this mariculture, in countries that are in development to provide jobs. Also because the temperature is better for growing the species usually.
I thought it was colder weather that we want.
Depending if your species. If your species is a salmon, so a temperate species, you need to be in the temperate. If your species is a tropical species, you need to be in the tropical.
That's fascinating. Let's go back to some of your maps here, or some of your slides.
Cooking great salmon, that's easy. But finding salmon that's consistently great, it can be challenging. Until now. Because now you can order Mowi salmon online from Amazon Fresh. Mowi's fresh, sustainable, high-quality salmon is available to more people than ever before. And that means a healthy, affordable, quality dinner is just one click away. Because the only thing better than great salmon is great salmon delivered. Salmon is good. Mowi is goodness.
So this is how we can predict the distribution of a species. So in this case, it's the Sensi trout. What you're seeing is basically on the left side, you see all the black point is all the little black point are where the species has been observed, and all the blue polygons, you see this all blue.
Right.
It's where experts say that the species is. If you look at the east coast of America, you can start to see dots that are not where the experts said that the species is. You see on the figure A?
Yes.
You see that it's going up to New York?
Right.
Yes. So the expert didn't expect for climate change.
Amazing.
And so those dots are the species starting to go poleward to catch their temperature. Right. And so on the right side is the model. So you can see we can zoom at that level and tell you yellow means that it's better for the species, and blue on the top means it's less good for the species. And we can catch, if you look at it, the model is predicting where the species is, where the dots are. And on the bottom part is how this distribution is going to be in the next 50 years. And that's for the worst case scenario. Red means it's going to be very bad for him, and blue means it's going to be very good. And what you can see is that, for example, the Sensi trout in Florida is going to most likely disappear. And next to New York and in the north, in the east coast of US and Canada, the Sensi trout is going to appear.
Are there, I sometimes hear about stories where in the Amazon, because of climate change, suddenly these new species have just popped up.
You can change the slide on the right.
Yeah, let's go to the next slide. We'll take a look at that. What happened?
Continue, next one. Okay, so basically, and that's how we predict. So we were talking about this fancy machine learning model. Let's be honest, the theory behind it is pretty simple. The idea behind that is an environmental window. So basically, you remember when I told you you have a preferred temperature.
Right.
We can go more far. There is a temperature where you and me, we will die. It's too cold or too warm.
Hot.
Imagine that you didn't regulate your temperature. So same story that I gave you with the species. You will follow your favorite temperature.
Of course.
If you're a fish.
I'm going to Florida in the wintertime. And I'm going to go
Snowbird.
right. And I'm going to go to Montreal in the summer.
Go to Vancouver.
Or Vancouver. That's fine, where you're from. So, and this is what...
And that's literally what they are doing. Migration. Yeah. What is migration except trying to catch your perfect temperature?
Sure.
And in climate change, if you increase the temperature of the water, what species is gonna do? One of the unfortunate thing of living form is that you can adapt easier to the cold than you can adapt to the warm for biological reason. Basically, your physiology, if you think about it, you in the cold you can adapt. You reach a perfect point, and then a couple more degrees more in the warm, and you feel uncomfortable. And you think about it, it would create a curve of growing and a setback. Same for the species.
Right.
And so the problem that they have now is that the temperature is getting warmer. So what they are doing is that they are performing a migration poleward to track the temperature. And so we start to see, like, for example, the bluefin tuna, for historical reason, was between the Mediterranean Sea, Spain to New York, Florida. Now we can see it in Norway.
That's insane. The largest tuna ever caught in Norway.
In Norway. It has never been seen in Norway before. And now it is the largest. This is, by the way, that's the size of a bluefin tuna. Now you understand with the $250,000.
Yeah, no, that's very big.
We start to see sharks, tropical sharks in Vancouver. In Vancouver, we start to see the soulfish in Vancouver. And one of the things that I wanted to talk about with this, we're talking about species that can move. So that's cool for them. They are moving nice. We have white shark in Halifax.
Pack their suitcase and go to warmer.
What about the species that cannot, such as
coral reefs? Yeah,
they are just bleaching. And one of the questions that I have often is it that bad that the coral is bleaching? My answer to that is it that bad to erase half of the Amazon forest? Basically, the coral reef is the equivalent to the Amazon forest. A bleaching of the coral reef is you taking a saw and cutting all the trees of the Amazon forest. That's the equivalent.
Yeah. And this affects not just the fishing industry, let's go
Everything.
that way. Tourism industry.
Carbon sequestration, tourism, everything. And those species are way more slow to migrate because they migrate in a different biological cycle. It will take them, it's harder for them to go. And there is plenty of initiative to help them to move. The problem is that climate change is going faster than we thought. We are in the potentially one of the worst case scenario for now and since a while. Right. And nations are not, some nations are doing a good job. Right. Some nations are not.
Let's not name names now, okay?
I am on a working visa.
Right. Interesting.
So basically, it's kind of dangerous. So this was the map of biodiversity on the old one, on AquaMap 1.0. If you click, this is AquaMap 2.0 at 5 kilometer resolution. And this is the number of species per pixel, so by 5 kilometer to 5 kilometer for all these region. And the black line that you're seeing is the EEZ, Economic Exclusive Zone, basically what a country owns on the ocean, 200 nautical miles from its coast.
I see, it's their border, so to
There are
speak.
borders in the ocean. And so if you click one more time, so it's nice to know the amount of species. So that was the previous slide. But this slide is telling you how rare is your pixel.
Huh.
So if, for example, you're in the Galapagos, you see on the bottom left, bottom right, the Galapagos is among one of the most rare places in the world. Meaning, maybe there is a bit less species, but those species are only in the Galapagos. So if something happened in the Galapagos, all the species will are done. And if you look at the big map, you're going to see that it's not often where there is the most species that you have the more rare species. It's decorrelated. And so we provide this information to the nation.
Are we seeing this giant migration north and south because
Yes,
of this?
it's a mirror effect.
Yeah, and so in the equator, we're going to see less and less.
Next slide.
Yeah, there we go. Look at that.
And that's
And there
the
it is.
projection of climate change. So red means that we are losing species, and blue means we're going to gain species.
That's incredible. It's going to literally alter the business. I mean, everything. Tourism, business, how we eat
all
fish.
the blue economy.
Everything's going to go north. Everything's going to go south.
Yes.
And right in the middle.
And we think that we are optimistic. We think that most of the invasion in the north will be blocked. And we are pretty optimistic about the climate change. We think that some pixel in the world, so some region in the world will lose of about, in the worst case scenario, of about 70-80% of their biodiversity. We think, you can click one more time. So this is for basically saying, this is all the case scenarios. So best case scenario that, unfortunately, you see the map on the top?
Yes.
So basically that's the change of biodiversity by 2100. And you see there is three cases, 2.6, 4.5, 5.5, 8.5.
And what is that?
That's the scenarios. Best case scenario is 2.6, middle case scenario is 4.5. 8.5 is what we are doing now.
That is absolutely, that's scary.
Do you remember the 2.6? Do you see that's the
Yes.
best case scenario? You remember the agreement in Paris?
Yes, the Paris Climate
That's
Accord.
that.
We're not even close to that, are
No,
we?
more importantly, we already signed, that some nation didn't sign those agreements.
Right.
Currently, we cannot reach the Paris Agreement anymore.
Right.
Like the objective of the Paris Agreement, we cannot do
We've
it
moved
anymore.
that bar.
We are too
Yeah.
high.
Yeah.
So we will be between 4.5 and most likely 8.5.
All the way in the bottom
Yeah.
where it's dark red and there'll be less species
This
than
is the
ever
percentage of biodiversity that will disappear.
by the year 2100.
Yeah.
That is frightening.
Of course, we have uncertainty. That's a neurological question. This uncertainty, we computed them. You can skip that. So this is how my work is presented in the United Nations.
Right.
And skip. This is the label on climate. So basically, as you can imagine, some species will be more at risk than
Right.
others. And so that's the crib. And so now there will be a label next to MSP called the crib index, telling you if a species is at a medium risk, high risk, or extremely at risk with climate change. So if you don't want to eat a fish that is already very affected by fisheries and climate change, you will have that information.
Fantastic. When is that happening?
It's
the
the science
works.
is here. Now we need to find people that are willing to go with it.
Okay. All
It
right.
will start most likely in Canada, in Halifax.
I'll make some calls.
Oh, that would be awesome.
Yeah.
And so that was the new ecosystem emerging. So you remember I told you that everything is going poleward.
Yes.
And your first question was, what is happening in the center?
Right.
It's a new ecosystem.
What? Are we gonna have
So
new
look at-
species? Are
look-
we gonna have like?
New species we don't know
Yeah.
because I cannot. I'm a scientist. I have the right to say I don't know.
Right.
And if you look at this slide, you see all the ecosystem of the world in the ocean. Each color is one ecosystem. And so if you recognize the colors, so the numbers, 2.6 was the best
Right.
case scenario, 8.5 was the worst case scenario.
Right.
And you see in the middle, you start to see something white.
Oh my! On the 8.5, there it is.
Yes. No, you can see in
Yeah.
2050.
Yeah. That's
So-
now in 25 years.
yeah.
What is that white? The we don't know.
We don't know.
The black hole or the
It's-
white hole in this
it's
case.
a warm, it's a temperature that is warmer than everything that we have seen in human history. I said human history. We saw it at the geological time.
Right.
But in the human history, and so in the fish history that have evolved with humans, we have not seen it.
And we don't have fossils that tell us kind of what was
Yeah,
happening
but
there.
knowing what happens to the fossils doesn't mean that it will be applicable to the fish of now. Because the fish that were there during the fossils,
Yes.
have you seen what was the name of that crazy movie where there is a shark of 50 meter long, like in Jurassic Park?
Right.
Did
right.
you
right. I remember
Do you
that.
expect species at the Jurassic to be still here? No.
No. of
Like
course
dinosaurs are not
No,
here
we've
anymore.
evolved, Right.
So we cannot extrapolate what is in the fossils to
Right.
now. What we know is the ecological property of all the species of now that have evolved with us with the current climate. The question is, can they adapt? And the answer is no. It's too fast.
Right.
Most of the species have a turnover, meaning that to replace the full population, like us, the famous generation time, the turnover is between 1 to 3 years for most of the fish that are exploited. You don't have the time to adapt. You don't have the time.
No.
You can move a bit your boundary, but you don't have the time to get most likely warmer. Some plankton can, and I've already shown some sign of it. But a tuna will have a generation time of 11, 12 years. No chance. He will migrate.
That's frightening.
So we don't, in the center, we actually don't know, which will represent from 10 to 40% of the global ocean. We don't know what's going to happen there.
All right. Okay. Let's
Continue.
see what else, yeah.
So we created a model
Yes.
and continue to know the fisheries. How much fish can we catch in the future? So we evaluated. So what you're seeing on the left, I'm just going to take the worst case scenario because that's the most likely to happen
Of
for now.
course. Yeah. That's where we are. As long as we're
And
going.
so if you look at the lines here, you see the decrease of the biomass, meaning the amount of potential fish that you have. But having fish in the ocean doesn't mean that you're going to catch it. So we created a model to say how much of this part of the biomass do we catch. So you can click. And this is, so on the left side, is the amount of catch that we're going to lose per degrees of temperature that we're going to gain. So basically, what you need to remember is that, so that's the map. So red means you're going to lose. Whatever going to happen, you're going to lose. Blue means you're going to gain catch. And you can see that there is way more red than there is blue first. So there is way more loser of climate change than there is winner. And in any case, overall, for every degree, you're going to lose between 2 to 4% of your catch.
To what extent?
What do you mean?
And then what?
We will be dead, my friend.
We don't have to worry about it.
Depending if you worry for your kids.
Yeah. My kid doesn't like it. No, I'm kidding. He's a picky eater already, so... Oh, man.
The good thing is maybe you will not have the choice.
That's true. There'll be less choices.
So if you... It's a simple equation. If you remove the biomass, if you remove the catch, if everything is concentrated in the same place, and if everything becomes more rare, the value is going to increase.
Yeah.
And so you're going to have less and more expensive.
Right.
And so the people that are in the center, they're going to lose their work. They're going to lose their economy of fisheries. And only the winner of climate change, of the catch, can sell at the highest price. And it's the high latitude country. So right. Norway, Russia, Canada, North states of US, right. And by opposition, on the other side, Chile, New Zealand.
Fascinating. That's absolutely fascinating. We're coming to a close here a little bit.
I can speak about climate change for hours.
We can talk about climate change for hours, indeed, but we only have about less than an hour on this show. Give me some hope. Give me anything that's going to keep me saying,
we can still reach 4.5. You remember I gave you... So I misled you. There is more than 3 scenarios. There is 8 scenarios. We have still the possibility to reach the medium one, the lower and the medium one. We can adapt the future. But that means that every nation needs to make an effort. Second, we are maybe overfishing, but we have the numbers now, and we have the jurisdiction in our EEZ. We can provide sustainable fisheries for everyone. Third, aqua farming or mariculture or just culture in general, if we invest in it, there is place where we can produce the biomass. We have, with these 3 species that we are currently farming, you can make a lot of biomass. You can feed a lot of people and let the natural resources in the ocean alone to rebuild. But that will ask for a huge investment and place them in a smart way, in a climate smart way. And fourth, let the nature alone. They can rebuild. We saw that during COVID. You remember when during COVID, when we let nature alone, things come back.
Yeah, the dolphins in Venice.
Things come back. Yeah. Let things alone for a while. Respect nature, and usually things come back to a normal state, or degraded, but not at a point where they disappear.
Right. Boy, quite a lot to unpack, and also a lot of hope there.
There is hope.
Yeah.
There is, people can adapt. Society, it's not the first, let's be honest, it's not the first time that we need to have a agricultural revolution. Some of the world war started because of this reason, because we didn't know how to produce. The First World War, one of the trigger was we didn't know how to farm extensively. And it's after the first green revolution that we knew how to use the azote component.
Right.
And that was after the First World War. And then we could produce enough with the terrestrial. we don't know what the technology is going to bring to us in the future. We cannot count on it because you cannot count on something that you don't know when it's going to happen. But you can think that potentially we will have a blue revolution. Nonetheless, we are hitting a wall now. Climate change are moving species, and we are overfishing a lot of species. And aqua farming is not perfectly placed in the world, and aqua farming doesn't have enough money to expand. So by hitting a wall, we need a new revolution, and that's where we are. So there is the hope. People could adapt in the past. That means that we can adapt in the future.
Okay, I like that. And on that sentiment, we'll leave it at a high note. Gabriel Reygondeau, thank you so much for being on the show.
Thank you.
Wow, I really want to go on aquamaps.org and look at when 2.0 comes out. Anything you want to tell our viewers on how perhaps they can get involved with the AquaMaps?
They can reach to us. So basically now we are at a stage where the AquaMap 1.0 is on the website, right, that I'm pretty sure you can put our credential. Now we are at the point where we are raising money to develop the second website, because to give you an idea, the first website was 800 megabytes, so basically a movie.
Right.
AquaMap 2.0 is 10 terabytes, so that will be the database of a bank.
And it needs funds for that.
And we need funds to develop a new website so that people, as an individual, you will know, like if you go in a place and you want to show to your kids, that's the species that are in that beach or in my beach, we will have that for you. For experts to protect, for United Nations to create new marine protected area, and for countries in development to know how rich they are in biodiversity.
And how can they do to donate for that cause?
They can reach me.
They can reach you directly at aquamaps.org, is that right?
By email.
Via email. There's got to be an easier way. We have to go.
Instagram.
What's your Instagram handle so we can tell everyone out there?
At AquaMap. Without S.
Okay. At AquaMap. Go check out at AquaMap, and you'll be able to find Gabriel. So incredible to be on the show. Thank you so much. Hopefully,
thank you for inviting me.
You are doing amazing things, and we want to have you back in a year to see what the progress has been like, and once AquaMap 2.0 has gone up.
I wish. We are working very hard to put it online.
Fantastic. Thank you so much. And folks, thanks for joining us here in Decoding Seafood by Mowi. I'm your host, George Duran. If you like this podcast, please subscribe where you subscribe to podcasts. And also you can watch us on Mowi Salmon TV on YouTube. That's a YouTube channel, Mowi Salmon TV. Just check it out. And you can actually watch this podcast as well. Until next time, again, I'm George Duran.